All right, our next speaker is a level 3 thermographer and an ITC trainer with a lot of insight into electrical maintenance for heavy industry. He's even co-authored a book on electrical motor maintenance. Today, Geoffrey Generalovic is here to talk about risk management in predictive maintenance and how infrared can help you avoid risks. Please welcome Mr. Geoffrey Generalovic.
Good morning.
Good morning.
How are you today?
Good.
Morning. All ready to go for lunch? Usually about that time, right? My career started in 1994. We bought an Agema 550 because our industry back in the early 90s went through a severe downturn. We had our first layoff at the FASCO since it had started in 75 years earlier in the early 1915. We realized then that we had to do things differently. Run-to-failure maintenance was not an option anymore. So our people decided that we needed to do something different and start doing infrared for electrical systems. So we bought a $100,000 camera. I keep asking in the classes how many people would be here if the cameras were still at $100,000. And I think there wouldn't be many. So this is an image that I took in India. I was involved with risk analysis for a global risk company, contractor near my hometown in Hamilton. Actually asked me if I'd be willing to work for them. And as you can see on this image, that there are a couple of hotspots on a high voltage system. So this is where risk starts to really play into it. If any one of these issues can develop into a serious problem in that the plant the plant would be shut down if this failed. So what is risk? It's a probability or threat of damage, injury, liability, loss, or any other negative occurrence that is caused by external or internal vulnerabilities, and that may be avoided through preemptive action. How's that for a mouthful? But the probability is the part that we're going to explore. What we find now is that a lot of the standards that are available to us today, CSA Z462 is the workplace electrical safety in Canada, NFPA 70E in the United States. But they have now decided that they need to break out hazard and they need to break out risk. Hazard is the source of potential injury to a worker, and risk is a combination of the likelihood of an injury and its potential severity. And then when you get to NFPA 70E, which is a further extension of this, it includes guidance for making hazard identification and risk assessments. CSA Z462 does the same. Which then helps with PPE requirements and various other things that keep the employees safe. There are also various standards across the world. The ISO standards are starting to develop. This one is 31,000 Risk Management Principles and Guidelines, and it outlines what risk is and how it will prevent a company from reaching its goals and or objectives. Risk needs to be identified, analyzed, and evaluated, and by doing this, risk can be controlled. So this is where infrared for a lot of electrical systems and a lot of systems comes into play. ISO 55000 is asset management, and it actually tells you how to take your assets, analyze them, and put them into a system where you can identify what needs to be done and how to do it. 55001 is asset management. It is the system requirements. In other words, you've decided that you need to manage your assets, and they start to lay out the requirements needed to start that asset management. And then finally, 55002 is the guidelines for the application of 55001. It outlines what is involved in the management of assets and the risk associated with that program. So in other words, how am I going to manage my assets? What will work best to manage them? And most importantly, how does one develop a program to monitor the equipment to determine its condition? And for us here, it would be using infrared. So the standards also start to get into defining what a qualified person is and what a competent person is. Qualified person is one who has the skills and knowledge related to what they're doing with the necessary training to avoid risks. And hazards, a competent person is having the suitable or adequate but not exceptional or sufficient skill, knowledge, experience for someone for that purpose. So in other words, they're separating the qualified from a competent, and qualified is training. And I think the key for any system like this is adequate training, and I think ITC does a fabulous job of doing that for infrared thermographers. So a risk assessment determines what the risks are, usually identifies the hazards, estimates the potential severity. So I think risk and criticality of equipment sort of go hand in hand. If you have high risk, it's highly critical equipment, and that equipment needs to be examined in some way. Data needs to be accumulated on it and needs to be monitored by the company so that they can address and or fix the system as time permits. So predictive maintenance, I'm kind of leaning away from the word predictive anymore. I kind of like the idea of condition-based maintenance. Because a lot of people see predictive and they think that as soon as you start doing analysis with an infrared camera, you can tell them when the thing's going to fail, and that's not possible. But it does lend itself to, it is better than preventive maintenance. That's what they asked me to do when I started back in 1994. They asked me if I wanted to do predictive maintenance. And I think today, condition-based maintenance is a much better moniker for what you're doing. Using PDM minimizes a lot of risks. So using the infrared camera will identify any potential problem, which then would be a risk to the system. If those risks are not addressed and worked on, then eventually the equipment could fail and cause damage. Usually, a lot of the failures are the collateral damage is worse than the system, than the initial repair if you had done it in a timely manner. A lot of insurance companies today actually demand that all of your equipment is inspected at least once a year, and you need to prove to them that that is the case. The risk company that I did the contract work for actually supplied a thermographer once a year in various companies to do that inspection. Preemptive action reduces your risk. So in other words, as soon as you get some information, that action will prevent that from getting worse, and then hopefully you're going to make a timely repair, and with that timely repair, eliminate the problem. Severity criteria, again, with PDM or with risk management is I think the two sort of go together. Any kind of severity criteria is attached to risk. So if it's very critical, then it's highly risky to not do some work on that equipment, especially when you've got information from your infrared camera. Equipment criticality determine if it is scanned or not. High criticality, high cost or loss of production, so then then it identifies with large risk. So yearly inspections of high voltage equipment and all other equipment is important. Starting from the main incoming, a lot of people neglect to look at the main incoming. A lot of times, due to safety factors, a lot of the high voltage equipment cannot be inspected. But with the advent of infrared ports and various other devices like that, you can actually mount them and place them properly and do the inspections without having to open a lot of doors and to expose your workers to high voltage. And for critical supply systems, overhead bus duct compressors, you name it, again, if it's a risk to the system, there's high criticality. With high criticality, then the demand to respond to any information that you find via infrared or vibration or motor testing demands that you would react as quickly as possible to mitigate risk. And then talking about insurance companies, thermographers themselves need to make sure that they make sure that they are insured against any kind of problems due to their going out and doing that inspection, which would be errors and omissions or personal liability insurance, and it's something that's really important to consider if you're going to do that type of work. So these are the cameras that I've used. Our cameras are on the top left, P65 HS cameras. We used them extensively at the company I was at. Those cameras were out 5 days a week, 6 hours a day. And of course, then we have the Fluke versions, and then of course some of the newer equipment via the FLIR advertising. And as infrared is not just limited to electrical equipment only. Typically, you're looking at bad connections, high voltage issues, etc. Mechanical becomes a big player in it. When I first started, we bought the camera totally for electrical inspections, and then as time progressed, we ended up doing a lot of mechanical work. And we do a lot of furnaces and ladles and torpedo cars, various other systems as well. Tanks and vessels, building envelope is now big. When I first started buying a camera of that nature to do a home inspection, wasn't cost effective, but with the reduction in price, a lot of people do home inspections. Medical diagnosis, it's growing. Veterinary in the same application. So again, if you have a very, you yourself are very important to you. You want to make sure that you get early diagnosis. With early diagnosis, you get early treatment, and hopefully you're healthy for a longer period than if you hadn't, or had ignored the indications that you had problems. Then, of course, production assessment. So infrared is used because, again, like we've probably seen in training, actually this image is from a training manual. It's non-contact, keeps the thermographer out of danger, and it doesn't intrude or affect the target, which is a fantastic system. I mean, since 1994, the images that I've seen and captured have just been phenomenal. Again, here we have another one. This one was in India as well. Again, main incoming, high voltage switches. As soon as you, with thermal tuning, proper thermal tuning, these can show up very, very well, even on a sunny, bright day. And each one of those is an issue that could cause a severe outage. And again, that means that they're ignored at your own risk. Even low voltage systems on critical equipment can yield incredible results using an infrared camera. Again, don't ignore them. They can come around and bite you in the future. And then infrared for building assessments, moisture. So again, as was spoken about in many papers earlier, is the inspections of building envelope to keep you comfortable, to keep you safe, also to prevent excessive damage to the equipment. Any moisture leaks can be identified and repaired in a timely manner. This is one that was kind of interesting. My daughter was looking at buying a house. I took the infrared camera with me, and I found a leak around the skylight. And the leak actually went all the way from the skylight in the cathedral ceiling all the way down, as you can see through the various images, right to the floor. Looking at it afterwards, I thought that they had looked like they had painted the house afterwards. So I'm just wondering if this had manifested itself on the surface and they had painted it afterwards. But I told my daughter I think it's not a good idea to buy this house because of this leakage. And the real estate agent or the selling agent was very upset. She did say that it was under warranty. So therefore, everything would be okay because it's still under warranty. And I said to my daughter, warranties don't always do what you think they're going to do. Here was one with a building, and you can see a lot of the windows are actually in a failed state. The argon gas between the panes has leaked, and you can see all the various windows are showing the characteristic image of a failed window. Here we have a roof moisture problem. Again, one on the left, one on the right. You can see moisture problems incredibly well with an infrared camera. Need a tank level, you can always bring out your camera and do tank levels. Large animals, large animals can't tell you where it hurts, so infrared can help. First thing a vet does is feels for heat, runs his hand over the animal, over the various parts of the animal to see if there's any issues. Infrared is a fantastic tool to show them where it is, and I believe that it's happening more and more using infrared for that type of stuff. Humans, again, it's easy to see with an infrared camera. Again, where does it hurt? You can actually see it with the cameras, and with that, a proper diagnosis can be made and proper treatment implemented, and then hopefully you're healthy in a short time. Etna, this is a very good image of Etna. You can't see much through the smoke, but with an infrared camera you can. I believe there's various volcanoes that are active around the world, and they are being monitored with infrared cameras, so you can actually pick stuff up on the internet to view this sort of thing. Here was an interesting one. Infrared by walking around is a process to image equipment. This motor was running 140 degrees Celsius, which is pretty hot for a motor of this type. It's 250 horsepower, not easy to replace. It's not one that you're going to find on the shelf in a motor repair store, or it'd be a slow repair as well. And so I did some investigating. Again, this is part of the process, is the human element, ears, eyes, nose, and you pick up on this sort of stuff. So you can see that the fan end of this motor was extremely clogged, and with that the temperature raised to a dangerously high level. If it stayed that way too long, it would eventually fail. So you can see that the grease was on several of the motors, so we implemented a cleaning process, cleaned the junk off, and we had the motors reduce temperature from 140 down to 40 degrees C. So there's like I just said, the sensors are the ears, eyes, and nose of the inspector. You need to people looking at the equipment. The problem is that with the advent of workforce reduction, there's less and less people to do the walkabouts. And I think they're still an extremely important part of the process, but like I said, there's less and less people. And of course, infrared will identify the equipment that needs work, and with that, you're going to apply the limited personnel that you do have on the proper jobs, not on busy work. And this was kind of an interesting couple of finds. We had a couple of raccoons. One here on the bottom, on the right-hand side, you can see the result of him touching ground on our VAR yard and blew him up. And I don't even know how the other one got that far into the switch. You can see his back end up over the switch, so he must have touched the switch and then touched the roof of the switch, and he was now part of the switch. So how do you prevent stuff like that from, whoops, put the wrong button. Again, this was infrared by walking around, a switch in the middle of nowhere, sitting at 110 degrees. It was an important switch for a bypass system, and you can see that it totally melted inside. Again, having your infrared camera, infrared by walking around is definitely a process. Doesn't always have to be a PM and a route. Sometimes getting from point A to point B with your camera on will identify some very, very interesting finds. Again, floods in basements. This equipment was working just fine, but again, it's in a very bad shape, and eventually it could fail. It's good to identify this type of stuff, get it fixed when you can fix it, and not at a time when it will shut you down. Switches, again, easy to find with an infrared camera. And we actually had they were monitoring energy usage in a couple of the mills that we were on, and just doing the infrared scans and finding large switches like this with elevated heat signatures reduced our energy consumption as well. And then belts, of course, improperly adjusted or tightened belts cause issues. The belts will fail if they're submitted to high temperatures for a long time. And then, of course, arc flash, NFPA 70E, CSA Z462 are reducing risk to the workers. They outline what the PPE and its proper use is. And again, infrared sight glasses can be reduce the risk to the workers because they don't have to open bolted panels. Ultrasonic surveys are also another part to this process, and ultrasound can be extremely important or helpful in identifying issues. And of course, if you have two technologies telling you the same thing, then you have a powerful case to be made. And there's several manufacturers. SDT is one, UE is the other. If you ignore some of the finds, you may end up with this kind of an issue. And as you can see, there's all the copper from this switch or this cable is actually now all over the wall surrounding the cable. Or you may have a switch where the switch actually fails catastrophically and causes huge damage. You can see how far the arc flash went on the switch where the workers on the left-hand image. So if you ignore your findings, you can end up in a situation where failures like this happen, and with that, you are down. Another thing that we do a lot of was high temperature applications, which is ladles. Again, issues with the ladles are addressed quickly because if not, it could end up with a breakout, and you could have molten steel spewing all over. So infrared can be used to scan all critical systems, electrical, mechanical, humans, you name it, it can be used. It reduces your risk. Routine inspection is the key to assessing risk effectively. If you do it on a routine basis, as was said the other day, there's 3 parts to an inspection. The art, which is your report, the science, which is understanding infrared, and then, of course, the technique. It's all about technique when it comes down to infrared scanning. Scanning all equipment in a timely manner on a routine basis, you'll minimize or reduce risk. You're not going to completely eliminate it, but it will help. And with knowledge comes power. Understanding your equipment via infrared is extremely important and powerful. And just some acknowledgements. I had some of the images from ITC, and of course my friend Jack Nicholas, who I co-authored the book with, and of course the internet for a lot of images. Any questions?
Geoffrey Generalovic. Thank you, Geoffrey.
Well, that's major slides.
That's a lot of stuff to cover. Well, there's got to be some questions out there up front here, Ron.
It's okay.
And over here, next.
So other than installing in, over here.
Sorry.
So other than installing, say, an internal camera, how would you see heat buildup on that one picture that you had up there where it was a breaker on the floor and it had blown up in the back? How would you see that?
Well, we had a habit of opening the doors and then scanning around the back. And we got to a point where we could actually identify via temperature if there was any kind of issue. Didn't always catch everything, but it was helpful. And then we got to the point where we actually started to look at ports that we mounted along where the bus was. We put a port in the bus and you could scan through the breaker areas to pick up on any issues with the cluster and its male counterpart. Didn't catch all of them, as you can see, and sometimes loading is a big factor too, but it was usually we tried our best with our cameras to see around it. Yeah. Yep.
With regards to insurance, I have a plant that has hundreds of thousands of dollars per hour downtime. When finding anomalies, they would ask that the equipment not be shut down for the repairs until a predictable period of time that they can shut it down and do the repairs. Plant manager told me, he said if he does elect to shut down the equipment for any kind of maintenance or repairs, he pays all costs. If he lets it blow off the wall, the insurance company pays everything, including the downtime, including his employees' wages, et cetera, et cetera. So it's all costs paid if it blows up, 0 costs paid if he preemptively goes after it.
Okay, then
how do you argue with that? We all know the truth. We all know it should be done. How do you approach them on this?
Get different insurance?
I guess. I really don't know what to say in a situation like that. If that's his mentality, you're not going to beat it in any way that you could say about insurance. Insurance for us was it was a requirement. We had to inspect all of our equipment. And if we let it go, there were serious repercussions from our insurance company. We're a major steel company in Hamilton, Ontario. We had 12,000 employees. We got 5,000 now, but we need the insurance to be able to run. There is what's called downtime insurance, but I don't know what you'd say to a manager like that. The other thing too is, I guess, find it and then hopefully it doesn't blow up before the downturn, and then you can get it fixed. But if it blows up and he's willing to accept that kind of risk, I'd be kind of wondering about your business model if you're willing to let things blow up and then take the outage like that. I had one situation I wanted to put infrared ports in. They said no. And they were $400 a piece. So I said, I want to put 2 in on this switch. And they said no. $3.5 million later, they said, where do you want to put the ports? So it's all about, I guess you got to prove the case. And then if he's willing to suffer those losses, I guess there's not much you can do about it. I can't argue with that then. He's got a good insurance program, but how many times will they allow you to do that, though, before they eventually not give you coverage?
Yeah.
Right? That's the other thing, too, is, okay, they might do it on the first couple of times, but if it's a repeatable issue, then eventually you might say, we're not going to give you insurance anymore. That's the other side of it, too.
Yeah. Ron?
I have a problem with infrared windows where I can't really tell what what to set the camera at, because I may be dealing with different companies and different businesses, and you go in, and they don't give you they don't tell you what it is, and you come up, you can't open up the thing and look through it and all that stuff.
Rule of thumb, call it 40%. Because we found in most of these situations where we've done transmissivity tests, it's around in the 30 to 35% range. So call it 40% on any of the windows and then use that as your transmissivity. Measure the temperature of the optic or the window or whatever it is. So you put a piece of tape on, whatever, get its temperature, enter it into the camera, and call it 40% transmissive, and then do your imaging there. It won't be perfect, but it'll be close to better than just saying it's 100% transmissive. So then you can cover it for all the various different makes. Because theoretically, what you should do is get one of the samples, do the test, then enter it for that optic. So call it 40, go from there.
Okay, in the back.
Yeah, since I'm maybe one of the few here that represents the insurance industry, based on that last question, we pay out for business interruption as well, but there's very few insurance companies that wouldn't have any deductible. So the idea that there's zero loss if you let stuff blow up, that's not the real situation in real life. It's gonna hurt a little if you have a loss, and that's a good thing.
Yep. Yep. No, it's a requirement. Yep.
Hi, Geoffrey. Just a comment on the windows that you imaged. I don't know. Can you go back to that slide by any chance?
Which slide was that?
Possible? That's the window with a curtain wall. It's probably about 25 slides back.
25 slides back.
Yeah.
I don't know if I can. Doesn't look like it.
Anyway, comment on that. And I'm not disputing the fact that argon or the insulating gas could be missing in there, but I think it's.
The windows on the building.
Yes.
Oh, yes. Okay.
Yeah, where they have warm centers, because I think it's unless you have all the data, it's really hard to say where the argon mass is missing. Because I've seen those windows before. Yeah. And it's always a center of glass that appears warmer. And any window that still has its gas in it, like all the windows on these hotels, they all are convex or concave. As soon as they're a flat face between the inside and outside planes, and we know the gas is probably missing or they weren't manufactured with gas. So you're always going to have some sort of convex, which means that the glass is closer together, which possibly means more heat transfer between the thinner profile between the glass.
Well, the interesting part was that it was a certain percentage of the windows that had that characteristic as compared to others. So it was just I thought it was rather an interesting slide that shows that.
It's an interesting phenomenon. I've seen that before, but also there's been a really good study recently by an engineering firm in Canada where they actually tested windows right off the manufacturing plant, and the majority of them were missing or had low levels of argon. They can test down with the machinery to about 50%. Yeah. And there's a lot of them that are below that. These are right off the line. Okay. And so infrared this is a great tool to lead into that, but I think it...
Well, that gives you an indication that there's something going on, and probably further investigation might be required.
Could be, but if they're convex like that anyway, then maybe there's nothing going on, but you've proved that there's maybe nothing going on. Yeah.
Well, it was just somebody had made the comment, and I'm not a building expert, but it was kind of an interesting slide in that it shows you that. Again, like you're alluding to, further investigation needs to be required, but again, neglecting not to do it, or it might be detrimental to the environment for the workers. But I'm going to talk to you after about that paper. I'll be interested in seeing that.
Okay, big hand for Geoffrey Generalovic.